Hello again. Thank you so much to be here. It's a pleasure to be here presenting our job in this paper. So it's a proposal for a methodology to create artificial pancreas to control type 1 diabetes using machine learning with the automated insulin dosing systems. My name is Rodrigo Vilanova, and I am an entrepreneur in Brazil. And I deal with a company named Avantsec, and with a good friend of mine, Anderson Cerqueira. We did this paper. Anderson is a PhD student in the UNB, that's University of Brasília, in the capital of Brazil. So let's move forward. The scenario, the agenda is talking about the scenario, proposal, and the conclusion of this paper. Numbers. Let's talk about numbers. By 2034, unfortunately, there is a study that approximately 44 million individuals will have type 1 diabetes. The cost related to the complication of this disease is about $700 billion annually. I said billion, it's a lot of money. And this is because of retinopathy disease, amputations, kidney disease, hemodialysis, stroke, heart attack, and so on. What is type 1 diabetes? It's a disease when the pancreas does not make insulin. And why do we need insulin? Because we need insulin to deliver the glucose to get it in the body cells. In other words, without insulin, we die. We die because the cells need fuel, and the sugar is the fuel for the cells. So without insulin, we just die. A briefly history. In 1921, the insulin was discovered. In 1950, a tube sugar test was first attempted. The first blood glucose test strip was did in 1965. And in 1976, the glycated hemoglobin A1C test was made. This is a very important test today because it is one of the major indicative of the disease. How bad is the disease or how good is the disease? By 2016, the iCGM freestyle was approved by the FDA. What is iCGM? It's an insulin control glucose monitoring. The idea is to control the glucose levels in the blood by all the time. So this is the way we figured out how many glucose are in our blood. But we also need to deliver insulin in the body because, as I said before, the pancreas does not make insulin. So to deal with this, we use multiple daily insulin injection therapy. In my case, for instance, I do have diabetes type 1. In my case, I take up to 4 insulin injections per day. There is another situation. There is the insulin pump, also known as automated insulin dose systems. This is a kind of pump that is attached to your body, and it's delivering continuously insulin by the day. The comparison between these two systems is the first, the multiple daily injection insulin is cheap. It costs it's very cheap. But the cons is you need to get multiple injections per day. So imagine a little child that is afraid, that it has panic with needles. It's a huge problem. The insulin pump, there's no injection at all. You take one injection each 3 days, something like that, but it's costly. In Brazil, it costs something like $1,000 for a pump, but it can go up to $5,000 a pump, so it's costly. This is the scenario of insulin in the type 1 diabetics in the world. So what is the the sugar blood levels background. Today, there is no current cure for type 1 diabetes, unfortunately. In 2019, more than 1 million children and adolescents had type 1 diabetes. People with type 1 diabetes, if have adequate daily insulin treatment, can live healthily and delay or even prevent many of the complications related to the diabetes. The sensors can save up to 8 hours of the results of the readings. I mean the insulin continuous glucose monitoring device. The automated insulin dose systems bring flexibility to the patient's lives because there is no multiple injections anymore. The automated insulin dose systems are programmed by doctors. So this is the first part that is very important. There is no intelligence in the automated insulin dose systems. I mean, the doctor programmed it with a fixed amount of insulin to be delivered in the day, in a fixed amount. So there is no feedback from the insulin continuous glucose monitoring system for those adjustments, for instance. That's why we choose to make a closed loop to get a feedback from the iCGM and put in artificial intelligence to figure out how gonna be the insulin in the future of the patients. So the artificial intelligence in medical application, as everybody knows, has been increasingly being used to perform medical evaluation and diagnosis. But what about this is diagnosis, but we can use as well machine learning to make better and recommendation for the patients about the drugs, for instance, for the insulin, for instance. So machine learning can help to ensure that decisions are made as assertively as possible, assisting healthcare professionals in decision making. And that's the idea of this paper, to help the professionals to get the more accurate dose of insulin for each individual regarding this organism, because everyone has a different organism, as everybody knows. There is a kind of algorithm, the decision-making systems, that represents a holistic interdisciplinary phenomenon. And the decision-making system can trigger the automated insulin dose systems to administer the amount of insulin needed by the person based on his historical data. To do so, our methodology, our proposal is to get the information using data gathering. So we move forward to a control group determination. The idea is, what are the control groups to figure out what's the best way to deliver insulin for each person, each people. So after that, pattern research to figure out how much gonna be the insulin needed for each patient. And after that, the insulin prediction. Here is a kind of protection of the systems. The idea is, before sending to the automated insulin dose system the predicted amount of insulin doses, we need to have a kind of decision making to lock the system if it's necessary. I mean, we don't want it to die, the patients. So we must have a control using decision making to control if we are going to deliver the insulin at that moment or not. After that, a glucose prediction systems using time series is needed to predict how will be the insulin in the near future regarding the insulin delivered right now. And having this information, we have the result evaluation feedback to the systems. And when I mean feedback to the systems, I mean the sensor as well, the insulin continuous glucose monitoring, giving a feedback, a closed loop to these systems to help to have a better amount of insulin in the automated insulin dose systems. Obviously, we come back to the first step, to the data gathering, to increase the prediction accuracy of this model. So what is the data gathering? Here in Brazil, we have the GDF, that means, that stands for the capital of Brazil, the government of the capital of the Brazil, and they deliver the sensors for free to any person that has type 1 diabetes. Why? Because if you deal with the problem now, it costs much less in the future because of the complications of diabetes, as I said in the very first slide of this presentation. So it's better to get a better control now with this kind of program. But the problem is, here in Brazil, especially with the poverty, we still have social and digital inclusion problems. So to get the sensor, the person needs to fill a form for the government. And some guys doesn't have the ability to read or have problems. So there is a project named Avant Data for Good that get the information from the sensors and fill the papers for free to each individual and send it to the government. The idea is to get this information for the science proposal. So we are filling the forms to the person to get the sensor for free to from the government. But we also get information from the patients to make science. Having this information, the next step, as I said, is the control group determination using clustering techniques. So detecting the possible groups of patients with common characteristics, for instance, age, gender, physical activities, and so on. So for me, the glucose control are made with one amount of insulin that can be different from each of you. So how can we determine what are the control groups? What are the possibility or the needs or the problem that we are dealing with any kind of these characteristics that each individual have. The next step is the pattern research. Using a regression algorithm, the idea is to establish a function of a relationship with the independent variables with the estimated ideal insulin dosage per individual. So for each individual related with the control group characteristics, the idea is to say you gotta need 1, 2, any kind of universal units of insulin to deal with your disease at this moment. The next step is the insulin prediction using decision-making algorithms. So having the information from the pattern research and respecting their personal characteristics and receiving feedback from the closed-looping insulin continuous glucose monitoring systems, we are going to make the decision to give or do not give the insulin to the individual at that moment. So using this, we are proposing to have micro insulin doses. In other words, we can deliver the insulins like the pancreas do. So we are trying to mimetize the insulin work with this machine learning algorithm. At that moment, we are going to deliver or not, as I said, the insulin dose to the automated insulin dose system. Next, we have the glucose prediction using time series algorithm. So the idea is to estimate the glucose level in the near future. So it's a prediction according to the insulin dose given at that moment. So if I take the insulin dose now, how gonna be my glucose level in the next 5 minutes, in the next 10 minutes, and so on. This is used to get feedback from this model and get better results evaluation and feedback in the next phase. So in this next phase, we are talking about to compare what was estimated with the individual response. and refine the model, seeking for greater assertiveness in the relation to the current medicine administration process. Obviously, all this process must be accompanied by a doctor, who is the person that knows how to deal with this disease. And as I said, we give a feedback to the data gathering process phase to get again a new control group determination and to do the insulin predictions using decision-making system and glucose prediction and so on. So the idea is to have a kind of infinite loop in a global cloud with global artificial pancreas intelligence with continuously model tuning, and to deliver this kind of information to the local artificial pancreas that can be in your smartphone attached to your insulin dose system as well as the controlled glucose monitoring systems. Today, we do have data gather information use data for good, so we already have a lot of data in this data set. We are looking for sponsorship regarding the insulin pump because, as I said, it's costly. And we are building an MVP to deal with these questions today and in the near future. So with this, I finish my presentation and I'm ready for questions if any of you guys give me the pleasure to do so.